Alright. Hey, welcome back. Welcome back to game design. Hope everybody's game is coming along well. Yeah. Again, feel free to tune me out and work with each other in Discord if that's what you want to do. Keep working on your game. You can always come back and rewatch this later if there's something here that tickles your fancy. But today we're going to work on shooting, and we're going to work on bullets flying out of the gun and doing something, so the hitting end of shooting. If we have time, we'll work on events that are supposed to handle every second or half second or whatever, stuff that's supposed to handle periodically. If we don't, we'll cover that next time. And, you'll learn a little bit more about the physics engine and stuff today, too, as we look at bullets. But you've been following along so far. We got characters to move two ways, with character controller and with rigid body. There's also a third way that we didn't cover, which is just to move the transform manually. This is the most labor-intensive way, and also probably the least effective, unless you don't want the player to have realistic collision with anything. But it is an option, especially for kind of like, I don't know, like games where you're a spaceship or something and you just fly around, games where you don't hit things very often, or where hitting something will probably result in death. Those are options if you want to have a really fine-grained control over the player, is just moving the transform directly. That's also pretty easy to do, so if that's something you think that you're going to want to use, I believe the ship shooter example that I provided you mostly moves that way. So you can check that out if you're interested there. Okay, well, let's get started with today's thing. I'll get rid of my camera again. Let's go. Alright, here we go. I made a lovely little placeholder art asset for us to get started with. Let me see if I can find it. There it is. Alright. Are you ready for this? Here we go. Here we go. Da-da-da-da. It's a rifle. I made it out of cubes. Isn't that beautiful? Alright, let's just pull the rifle out on its own. We don't need the rest of the old player I was working on. Alright, so here's the rifle. All by itself. You'll notice that it's blue, which is something that we'll cover again later. It's blue over here in the inspector. Alright, so it's made out of bricks. This is a good way to handle when you have an object that's made out of multiple pieces, including if you have it made out of multiple art assets. But you'll notice that here I don't have any colliders attached to anything. So if your object's made out of multiple art assets, sometimes you'll do this where there's a bunch of different pieces of art, and they're all just like children of what is actually an empty game object here. And then sometimes you'll just have a single collider. Like if you cared about collision on this rifle for some reason, you'd probably make a single box collider, and you would probably just center it and scale it accordingly to, let's say, the whole gun, rather than making colliders for each part individually, because unless you really care about like fine-grained collision like that, this is probably going to be good enough for your purposes, and it's much more efficient. So when you do build complex geometry later, when you get to work on more art and stuff, keep in mind that you'll probably still be using box and sphere colliders for everything except possibly the player and other things where you really need that complex geometry in place. And I don't need a collider for this gun at all. In fact, most shooters don't have collision on the gun. The gun doesn't have separate physics to the character, so duh. Another thing you might have noticed is that I have this other child object here called bullet spawn, and it sits right in front of the barrel, and it is an empty game object. And this is pretty important whenever you're building something that's going to spawn objects that shoot out of it. So this bullet spawn here is the area where I want the projectiles to actually appear. This is really helpful because if you kind of spawn projectiles inside the object, so if you instantiate them at the object's point, well, they'll be instantiated at the center. So first of all, if the gun has any kind of collider, the bullet will hit it right away because it's instantiated inside of it. That's a problem, especially if your bullet moves by force. And you can use layers, or you can use script to ignore that collision and then move on. But the easier thing to do is just spawn your bullets outside of the object so they don't bump into the object as they come out. But for slow-moving projectiles, it's still possible to bump into the object, and in that case, this is still useful just because it looks better than things coming out of like the middle of your object. The best thing to do is also to play some sort of muzzle flare animation or something which hides the instantiation of the object so it doesn't just appear to materialize in space. But if you have a machine gun or something, you're not going to notice the bullets just phasing out of the ether anyway. Okay, so that's it for my rifle, the aesthetics of it. So there's not much else. I guess I can talk a little bit about some of the art that I did here, which is not of interest to you yet, but might be moving forward. So I imported two textures, just a true black, so 000 RGB black, and then a gray texture. And then I built two materials out of it. I built this gunmetal material, which uses the gray that I had, the dark gray, as its metallic instead of as its albedo. And if I kind of pan around, you see this thing has like a sheen to it. That's what happens when you use the metallic instead of the albedo. And the more you crank the smoothness, the more the sheen changes. So you can have different sheens, essentially, different metallic looking glows by cranking the smoothness to different values. So you play around with that as you will. Then the black portions of the gun, like the barrel here, are made of what I call the black gunmetal, which takes the black material for its albedo and then the dark gray for its metallic, which allows it to have that kind of metallic sheen in the dark gray color, while also having the true black color as its base. So you can see it still kind of responds to the glow of the sun. Let me just spin it around a little, and that's bad direction. Let's go this way. Yeah, kind of shines a little differently depending on how it hits the sun. And this will look different in the game than in the editor, where it really fudges all of the lighting effects for performance purposes. So once you actually build your project, you'll see the shininess quite a bit differently than you see it in the editor. It's something to keep in mind, that if you're doing a lot of different materials and stuff, you're going to end up having to build your project, look at what it actually looks like when the graphics card is rendering it in its true form. But yeah, this gives you access to both the kind of metallic sheen, which, ooh, look at that, isn't that cool, and to the base color albedo thing, so you can really have some fine-grained control there. Yeah, alright, that's metals. Okay, so let's move on to prefabs. We'll start with that, with the rifle, which is why it's blue. So I always have a folder for my prefabs, and prefabs are basically just objects that you can make copies of. And so if I wanted different characters to be able to have a rifle that looks like this, maybe I have enemies that have the rifle, I have players that have the rifle. To make something a prefab that's in your scene, you just click it and drag it into anywhere in the assets. And in this case, I'm dragging it into my prefab folder, and that would make this prefab rifle. I can now click the rifle in my prefabs here, and I'll go into this screen that's outside of the scene, where I can edit different properties of the prefab. Let's say that I wanted to make the barrel longer or something. So if I change the scale of the barrel here, and then I went back to my scene, you'll notice that it affected all the copies. So that's lovely. I'm going to undo that because that looks dumb. Oh boy. I can't. All right, we'll do it manually. There we go. All right. Okay. Yeah, no more undo once you back out of that scene, so that's a problem. All right, anyway, so I've done it. I put the barrel back. It affects all the copies in the scene. If I bring this one back over here with the player attached to it, you can see his is back to normal too. But the main advantage to making prefabs like this is that you can instantiate copies of an object, and obviously this is how we're going to do bullets and stuff. So let's attach this rifle to the rigid body player. Okay, so I've made it a child of him, and then I'm just going to kind of move it into position. Let's place it in his hands. Let's see, he's probably right-handed, right? You got to hold on to the clip with his right hand. We got to put that stock up against his body. Lovely. Very realistic. Okay, now my man here is holding the rifle. And now I need to make my guy shoot. When you click the mouse button, that's going to be my next step. So before I start shooting, I'm going to make a bullet that he can actually shoot. So I'm going to start with a sphere. Okay, I'll call this bullet alt. Let's get in there. Pull it out of the ground. Alright, and let's see, what size do I want to make it? Let's go with this big, and then run it up to my gun and see if it fits in the barrel realistically. It's kind of just, it doesn't have to be perfect, I just want to see if it's about the right size for the barrel, and yeah, sure, that works. It's actually bigger than the barrel, but hey, it's video games, so nobody cares. We're just going to have it there. And I'm going to give it my black gunmetal material. There you go, cool, black gunmetal bullet. It already has a sphere collider attached to it. Now, the smaller the bullet is, the harder it's actually to do collision for it. So if you want a really, really tiny bullet, you're going to have to make some accommodations that you would normally have to do. And one way to avoid having to get into this situation is just to make everything in your scene bigger. The bigger everything in your scene is, the better Unity's collision engine is going to handle it. So if you really want to avoid this problem in the first place, I mean, you probably should have just made this guy that size to begin with, and kind of gone from there as your baseline. When you're in the point where your bullets are like 0.1 units large, it becomes a little bit more challenging to handle collision. So as you get started, try to keep in mind bigger is better. If you can handle it, just make everything larger than scale 1, and it makes collision easier to handle down the road. It's easier to scale down if you started at a large number than it is to scale up. Okay, this is definitely going to need a rigid body if I'm going to move by physics. Now you can easily move your bullets without physics by just saying transform.position equals transform.position plus transform forward times some speed. This is a perfectly viable way to move your bullets if that's all you want, them moving in a straight line. We're not going to cover that because it's so dead simple, but there's definitely applications for that. I have to decide what mass to make it, so I'm going to cheat and look at the one I already made. Let's go with 10. 10 was a good number. Sometimes you don't want bullets to have drag, something to keep in mind. If you just want the bullets to go in a straight line essentially forever, then don't give them drag. Likewise, sometimes you don't want bullets to have gravity. Again, if you just want them to go in a straight line forever, you can turn off gravity on your bullet too. That's pretty much it for the early setup, so let's go ahead and turn this into a prefab. Remember, you just drag it into the assets, in this case into my prefabs folder, and lo and behold, I have this beautiful bullet as a prefab. Now I can now delete it from my scene. I don't need the copy in there. I just need the prefab. Next, I'm going to make a script that allows the player to shoot. So let's create a new script. And hello. Huh. Weird. All right, we'll call it player shoot alt. Lovely, and let's get in there and edit that guy. Go find my notes for this too. Okay. Delete these things because they bug me. Welcome to leave them. Okay, so let's start with where did the bullets come out of? This is an important thing, so I'll call that the bullet spawn. This is going to be that empty game object at the end of the rifle that I'd created. What did I do here? Oh, oops, I put it above the class. Yep, that'll do it. Okay. And now let me introduce a very useful feature that you should always be using when you're working with Unity, especially when you're working with others, and that's the tooltip. So above any public thing that you declare like this, what you should always do is leave a little tooltip about what it is. So let's call this where bullets come from. We know where babies come from. Where do bullets come from? And what happens is that when something has that script, so let's add it to my guy here, and now I can hover over this and it will read that tooltip for me, so I don't have to toggle back and forth between the code. This is very helpful. You can also use this to designate a range and stuff, or designate different criteria and limitations on that variable, so yeah, definitely leave those kind of comments behind whenever you make stuff like this. Alright, let's make a thing that you shoot, the actual bullet. So the prefabs that are constructed when you make copies of them, when you shoot, are all going to be game objects. They're not transforms. Remember, transform is just the property that every game object has, its position in world space. We actually want the whole game object, that whole prefab. So that's going to be, I'll call it bullet simple, because I'll show you some more complicated bullets later, and this is going to be a simple kinetic bullet. That's not a good explanation, by the way. I'm just trying to show off the tooltip functionality. All right. So the bullet spawn is simple. I want that tip of the rifle for this particular player. Notice I didn't use like get component for it, and it'd be annoying because it's like several like children down. But you could actually just fetch the bullet spawn by name or apply a special tag to it and fetch it that way. But much easier to just link it in the editor. And then what do I do for the bullet simple? So a common mistake is to take the bullet that you have like in the scene here, like this guy, and to add that guy to the player's thing there. That's wrong. Don't do that. And that will not link the prefab. That will link this particular bullet, which is not what we want. We want the prefab to be the thing that gets spawned. So there we go. The bullet that is linked to the actual prefab is the thing that's getting spawned there. Okay, on to the next thing. We have the bullet linked, the prefab. Notice its little blue box there. We did work with these a little last time, but prefabs can be confusing. And we have our transform in place as well. Let me see if there are any questions. Someone commented that my gun looks like the Warzone Mac-10. Hey, pretty fantastic gun. All right. So the simplest way to fire out a bullet is just going to be to apply a bunch of force when it spawns and just eject it in the direction that you want it to go, right? And that's how bullets kind of work in real life. So we're just going to shove the bullet out of the gun. Yeah. All right, we'll call this simple force on spawn. And we'll call it an update. And we're going to read the button for shooting. If you go to your player settings, you go to your inputs, you'll notice that there's a few different defaults for shooting. Fire 1 is the left click, mouse 0, but also left control. So you can use like WASD, and then you've got your left alt or right click, and or actually I think that's left alt or mid click, and then left alt plus, or left shift and right click is the last one. So those are your 3 default fire inputs. Obviously if you want something different than those, by all means. And then on the controller I think they correspond to the triggers, maybe something else. I don't know. That one's not as intuitive, I think, so up to you to plug in the controller and see what that's supposed to be. But of course, you can always rebind it for your project, no big deal. So that's going to be get button down. I'll use fire 1, which is the left click. And I have that in update, so that'll fire whenever the button gets pushed down. And now I want to instantiate a copy of this bullet and then obviously send it off along its merry way. So let's make one more public field for the force with which it shoots out. Bullet force. Let's say the force a bullet starts with in simple mode. And we're going to do building a bullet. So I'll call this bullet. And I'm going to instantiate that bullet at the spawn location. So I'm going to build a bullet simple prefab. And I'm going to build it at the bullet spawns. Actually, it's already a transform, so I don't need to call it that. I can just say bullet spawn.position. And this is the part that's a little bit confusing. What angle do I want to put it at? Well, luckily for me, I made my bullet a perfect sphere, so I don't care. I can just make it identity. But we'll play around with what happens when you have a bullet that's not a perfect sphere a little bit later. Then it gets a little bit more complicated. Now notice I had to say GameObjectBullet equals because I'm still going to do stuff to this bullet. I can't just instantiate it and forget about it because I still need to like add force to it and stuff, so I need a reference to it. So RB is bullet.getComponent rigid body. Still going to need that. And then let's add some force to it. So in this case, all I'm going to do is shove it forward. So let's go with bullet.transform.forward times, what do I call it, shoot force, bullet force, bullet force. And you might think that that's it, that you're done. And yes, it's true that that's all you necessarily need, but whenever you're instantiating a projectile, remember that there's one thing that you always need to do, and that's to give it a lifetime. If you don't give it a lifetime, then if it clips through the floor, or flies off the edge of the map, or simply doesn't hit something for whatever reason, then it will linger in your scene forever and consume memory. So anytime you build a projectile, you want to schedule it to be killed eventually. So just like in the little example with the cubes we looked at last time, I'm going to call destroy with some lifetime. You set this to whatever you want. I'm going to set it to 20 seconds in this case. So bullets will live for 20 seconds before being cleaned up if they don't hit something or do whatever it is that they're intended to do there. Alright, I'm going to need to give it some shoot force, and then I can try this out. Yeah, that's everything I need. Let's go. Bullet force. I'm going to cheat and look at what I had it at before. That looks like a good number. Oh, and I broke one of my rules. I forgot to set the mass of the bullet to something other than 1. Oh, no, I did. Okay, I set it to 10. That's cool. Alright, here we go, blue guy. Look at that, I'm shooting. Now my gun seems to have gone on without me. But let's look at what happens when I get shot. Oof, ouch, owie. Oof, 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 oof. You'll see it's actually pushing me. It's giving me some actual force because the bullet has mass, and when it strikes me I do move a little bit. You'll also see there's a bunch of bullets rolling around in the scene now, but just shoot a few dozen out and then just kind of wait 20 seconds and watch these bad boys slowly clean themselves up over the course of the next 20 seconds. So watch them vanish. And as the terrain is slightly sloped, you'll notice that they also roll around and stuff, which, if that's desirable for you, is pretty cool. Alright, next let's make the gun actually move along with the player. So I believe the reason that it didn't move along with the player is that it wasn't a child of the character controller. I believe the character controller is actually the thing that I move around, so let's see if that was the case. Hey, there we go. Now I can move with my gun. Eat it, red guy. Uh-oh. That's not exactly the way I want my bullets to go, is it? I want them to go forward relative to the weapon, not forward relative to the infinitum at the end of the world. Don't I? So, how do I make it go forward relative to the gun? Well, one thing I could do is, instead of spawning it at quaternion and identity, I could spawn it at bullet spawn rotation. Let's see what that gives me. This is going to change the rotation the bullet spawns at, which visually looks the same, but remember, it just starts moving forward. And that's basically all I needed in this case, because my bullet spawn was at 0, 0, 0 rotation, so the bullet just spawns relative to where it's at as the player rotates. Remember, it has this rotation you see here, but that's relative to its parent. If I dragged it out into world space, you would see that its rotation actually changes in world space as the character rotates around. So anyway, bullets coming out of my gun now. Let's show that again. Lovely. Let's hit red guy a bit and see, does red guy move? No, he doesn't. He just stays there like a brick. Why? Because he's a character controller and he has no physics. So if being able to be shoved out of the way with high velocity projectiles is important to you, then don't use a character controller. Use a rigid body like blue guy is. That's a lot of bullets. That was fun. Okay, so that's actually perfectly serviceable for most applications. If you really do just want the bullet to fly forward and go as far as it can, this is perfectly fine. There's nothing wrong with it. It's probably the way to go. But let's show you a couple of eccentricities here that you have to kind of account for. So let's make a cube. I'll call this Tisty Cube, not cube, Tisty Cube, and I'm going to make Tisty Cube kind of small, which is a pain because I actually have to hit him, but I'm kind of going to cheat and stick him right in front of where I spawn. Hopefully that's good enough. Okay, and now I'm going to crank up the bullets force to 10 times what I had it at before, and then let's play around with it. Alright. I whiffed Testy Cube pretty badly there. Let's rig it a little better. Sorry, it's a difficult demo to set up. Here we go. Uh-oh. They're just going right through him. Let's slow it down a little bit and see if that fixes it. So I'll go back to 1 less 0, and they still seem to pass right through Testy Cube. Let's move them up a little more. Maybe we're just not hitting Testy Cube. Let's try again. Well, still going right through him. Let's make Testy Cube a little bigger then. Let's go like that. Now we're hitting him. Let's make him a little narrower. And now we're going through him. Let's look at the terrain behind him a bit. What happens to the bullets beyond? Oh, they just go right through the world, don't they? Well, that's a little strange. That's not what we wanted. And I don't know. Let me slow it down a little bit more and see what happens. Well, now they don't even reach him, so that's irrelevant. But let's go somewhere in between. Oh, now they hit him again. And then let me make him narrower. And now they hit him still. And a little narrower. And now they go right through him. So, collision detection in Unity, not perfect, is the moral of the story. Especially when you're colliding with very small or very thin objects. If the object's moving really fast, there's a pretty solid chance it's going to phase through. And that definitely includes terrain, which is a height map, which by definition is always infinitesimally thin. So it basically is like 1 unit thick at all times, and things really have a tendency to clip through the terrain if they're moving beyond the speed limit. So solution 1 is to make objects move slower, or to make the things you're going to hit thicker. This isn't always an option, so what you can do as kind of an option of last resort is to go to the collider on your bullet, or on the thing that you want hit by the bullet, and change the collision from discrete to continuous. When something has continuous collision, it's much more precise, but it's also much more expensive. So having like 1,000 bullets in the scene that all have continuous collision is going to drive the physics engine pretty hard. So basically you want to limit the number of things in the scene that have to use continuous collision detection to, let's just say, several. Maybe up to 100 or so, depending on your application, is probably a good rule of thumb. So I like to make the player at least a continuous collider, maybe some of the enemies that are more important. But just bear in mind that if you use the default, the discrete collision, once you exceed the speed limit, you are flying straight through, baby. Okay, so continuous if you need something to actually collide for sure, but the best solution is just to play with your speed limits and thicknesses and make sure that things can strike each other even at their absolute highest velocity. All right, any questions on basic bullets at this point? Because we're going to move on to what happens when they strike things next, and then we'll double back to things that are not just shaped like spheres and have more complexity than that. Okay, cool. Let's move on to the bullet hitting things. Feel free to give me any questions if you have them. I'm going to leave this cube here. I'll actually make him a little thicker so that we can smack him on purpose to test out what happens on collision for us. Okay, so I'm going to go back to editing my bullet so that I can do something with it on collision. And I like to edit my prefabs by dragging them into the scene and then applying the changes from there. There used to be an apply to prefab button. Now it's somewhere else. But you can also edit your prefabs by going into that secret menu thing here. So I don't know, let's do it from here for now because I don't remember where the apply changes to prefab button is. So if you're going to play an animation when the thing dies, one thing to do to reduce the amount of instantiate and destroy calls you have to do is to bundle the animation as part of the thing, part of the projectile itself. So I'm going to create a new particle system. Those are the main kinds of animations in Unity. I'll call this the kaboom. And what I'm going to do before I finish here is I'm going to actually set it to inactive. And then when the thing actually collides, it's going to reset this to active and play its animation as the thing dies. So let's make a simple explosion. We'll look into the particle system a lot more, but don't want to show you something simple today. So let's change the shape to a sphere. We're going to make the speed really fast, like 20, but we're going to make the particles last not very long, so like 1 second. I'm going to take down all the emission over time and just make a single emission of a bunch of particles at t equals 0. Okay, so we're getting somewhere explosion-like. I'm going to reduce the duration of this animation. It should only be about 2 seconds long. Okay, so we're more explosion-like than we started. The lifetime of the particles is still too long relative to their speed, so I don't want them to expand out that far. Let's go with 0.15. Okay, but I also don't want them to just phase in and then vanish like that, so I'm going to change their size over lifetime to a curve, and I'm going to start the curve big and then make them small as they reach the end of their life. So that gives me a pretty natural looking explosion. I can also make them change colors, so I'll start them off as, let's say, I don't know, red, and then they sort of fade to white towards the end of their life, and that gives me a decent explosion, I guess. Obviously a lot more you can do to play with that, but hey, not bad. Crank down the speed a little, that's kind of too intense. All right. Sure. And then that's probably too many particles. Let's go with like 15. And maybe that lifetime is too short. Nope. That's a good lifetime. Let's go even shorter. Okay, the relationship when you're making explosions like this between lifetime and speed, speed makes it look like they're coming out faster, but then if you make them come out too fast and they last too long, then they're going to propagate out into your scene. It looks more like a firecracker than it does like an actual particle explosion. Okay, and then I'm going to stop this from looping. This is actually just supposed to play once at 0, so it's not a looping animation, and then I'll also turn it off. And I could also make a prefab out of this, so let's call this Alt, because that's what I did earlier. And I'll show you how to do it both as a child of the bullet and then as its own thing. So I'm going to uncheck it here so it's not active. That way, when this bullet is created, the animation does not play, and we'll see that when I create some bullets here and shoot them. Okay, those were my super fast bullets. Let me slow these down. when I create some bullets here and shoot them, there's no fireworks or anything going off when they get born into the world. But if you look at each bullet prefab individually, you'll see it does have that kaboom attached to it. And if I was to, well, if I was to find a bullet floating around in the ether, wherever it was, I would have been able to turn that back on and watch its explosion. Anyway, we're going to make a new script called Projectile Collide, and then I added an alt to it. That's what I've been doing for all the scripts I've remade here. Okay, and let's call this game object particle system child, and then I'll also have a private particle system that I will yank off the child at spawn. Or you could have just made a public particle system, but as you'll see, we need the game object attached to it. So let's do that actually, because that's a little bit more complicated. So we'll call that particle child, or like explosion on death or something, if you want to be more specific. Okay, so I will add that script to the bullet. Note that when we're not editing something like arty, we can always just add the scripts here. So I can always just add them to the prefab right in the inspector. I don't actually have to go into the prefab editor thingy. But I want to link to explosion on death, for which I do have to go into the editor thingy. So I've linked to its particle system. Cool. Okay. Now that I have a link to that. So I want to do something when this thing collides. So I'm going to do on collision enter. Remember we worked with that a little bit before when we were working on the character jumping. We had to use the character collider version, and then when we did the rigid body one, we used this on collision enter one. So I want to play this animation, and then I want it to kill itself. I want to remove the bullet from the scene. So I'm going to call the game object attached to this guy, and I'm going to set it to active. Oops. True. Okay, and then I want it to emit some particles. So I'll tell it to emit, let's say, 15 here. When you're manually emitting things like this, it's best to go ahead and turn off any kind of emission that you were going to do. So I probably set this back to 0 if this was the approach that I was going to take, because I'm doing all my emission manually in the script. And they will still emit in accordance with the rules that I set up in the particle system. Again, we'll go into a lot more detail in particle systems when you're done with your core gameplay, but I do want you to be able to just make some basic ones as placeholders for your real animations down the road. Okay, well, let's try that for now and see how that goes. I think I attached everything. Let's go and see. Anything happen? Let's see. Well, is the thing getting set to active? No. Did I apply this script to my bullets? Maybe I put it on the wrong one. There it is. There it is. And let's see if I'm actually getting some triggers of this script. Oh, I guess I just hadn't saved. Okay, cool. So we now have collision. But the bullet continues to live. Looks pretty cool though. Looks like a big old bloody explosion. Maybe a little bit too large, but we'll work on that later. But the bullet continues to live. It passes through the thing and then skids onto the ground and then smacks the ground later. And I think if we looked over here, we would get to see it continue to hit as it smacked the ground again. Nope, it just phases through there, so we just get those two collisions. But Every time it collides, it emits. That's cool, lovely. It's very therapeutic to watch. Nice blood splatter. Okay, onwards. So now I want to clean up the projectile when it strikes that wall. So I'm going to have it destroy itself. Game object. And if you don't pass a time here, it means immediately. So this is kill self. Immediately it cleans up the game object. So let's see what that looks like. Well, you'll notice that it sure does clean up immediately, but now I don't have my animation because the animation was a child of the object that I killed. And the particles go away when the particle emitter goes away. They're bound together in unity. So I want the particle emitter to stick around and continue to do its job. The easiest way to do that is to have the particle emitter become its own thing, so remove it from being a child of the bullet. And that's not so bad. Let's do that. So, whoops, not this. Particle, what did I call it? Explosion on death. Dot game ob. I want the game object that is responsible for that particle system. I want its transform. And I want to set that transform's parent to nothing. So setting it to null sets it to be the root, the scene. So if I include this one little change, now you'll see that every time a bullet hits that board, it creates a kaboom for me. Looks like it's kabooming on the other side here. And it's a very tiny kaboom. Let's look at that. Very tiny. Very, very small. Why is it so very, very small now? Why does my kaboom shrink? Well, now its dimensions, the size of the particles, is relative to world space. So if I look at my transform, it has a scale of 0.1 still relative to world space instead of relative to the bullet, where they were full size. So I kind of accidentally scaled them down to 1/10 by deparenting them without adjusting the scale. So I could manually set the scale back to 111 to counter this, or I could build my particle animation with this in mind and design it relative to the world instead of designing it like in this menu here like I did. So that's why I tend to modify my prefabs in the scene and then apply the changes later, rather than editing them in that prefab window where you don't have a concept of scale because it's like the only thing in the world. So what I should have done was gone into the world scene and checked out what my kaboom looks like here. I turn on looping for purposes of figuring out what it looks like as I'm editing it. And remember, I turned off emission here too, so I have to give it some particles so I can see it again. And now I see that in world space it looks like that at full scale, but if it was at 0.111 like I have it, then it looks like this. And so I can adjust the size relative to what I wanted it to look like in world space. But anyway, that's too much art for now. You should just stick to placeholders, so we'll worry about that later. Okay, but there's a problem here that you should have noted, which is that there were a bunch of animations there that would just linger forever because they weren't being cleaned up. So after you do this, of course, you need to also destroy the animation that you have now deparented because it won't get cleaned up when the original is destroyed. So now we want to destroy the explosion on death, which is the game object that that particle system is attached to. But of course we want to let the animation play out, so we're going to give it like 3 seconds to live. Right? And that's basically it for making the explosion a child of the bullet. Here we go. Boom, 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 boom. Now it is a little bit odd because the explosion kind of plays after you go through the wall, but that's again an issue with how fast the bullet is moving. Let me change this back to continuous here, and let's see. Nah, not really much improvement, unfortunately. I would have to crank down the bullet's speed considerably, or crank up its mass or something to get it to collide sooner. Oh, I am editing the wrong one. I'm editing my original. Change that to continuous and see. Yep, there we go. I get a slightly better explosion there. Whereas with the discrete detection, it doesn't detect the collision until the bullet's actually passed through the screen. And then the alternative would be to make my cube thicker again. If it was like this, I bet, yep, the detection would be right at the beginning. So lots of different options you can work with to make your collisions more realistic. And of course, you can always just set it to continuous. All right, I'll actually leave the other version to you, the version where the explosion is not a child of the bullet. That one is less preferable most of the time, but it is easier to work with because you don't have to worry about instantiation. I tend to favor that one when the explosion needs to have a particular rotation. So for example, if you're leaving a circle on the ground, like an expanding wave outwards, and it's always relative to the ground, you don't want to inherit any kind of rotation from the bullet, and so the easier way is just to instantiate that explosion at the rotation that you actually want. But that's pretty simple. You would just instantiate this game object at the spawn. So we're not going to go over it, but you can see an example of it in the collision not alt version that I wrote here originally, if you want to check that out, the version that makes the prefab. Let's move on to missiles and projectiles that are not spheres. Okay, let's make a, let's go with a cylinder. Yeah, beautiful cylinder. Where did it go? There it is. Okay, I'm going to call this missile alt. Alright, well, missiles aren't facing this direction, which brings us to an interesting decision. How do we get the missile to face, well, forward the way that we want? Alright, well, I can rotate it. In this way, transform right is what we would think of as forward. That works. I think one of the examples that I've given you, that's my universal reference point for missiles. Right is always forward, but I think it actually makes more sense, and I regret not doing this in hindsight, to rotate it 90 on X. This still has right as forward, but makes more sense to me for some reason. Anyway, up to you. Doesn't matter. Okay, let's edit some other stuff about our missile. It's obviously going to have to be a bit smaller than that. Again, let's go to our reference point here, the gun, and decide what looks like a missile that fits. Well, this looks a little too stocky and fat. Let's go with shorter, but then longer, something like that. These are just placeholder assets, so don't spend too much time with them, but it is useful to get the sizes approximately at the level that you're going to have in your production version, because, well, there we go. Because you're going to just be replacing these objects with their true art assets down the road. Okay, and then let's also give it a lovely black gunmetal finish. What a nice missile. Okay, one thing that I like to do as kind of an efficiency improvement is that capsule colliders are slightly more expensive than box colliders. And for a missile like this, I actually don't care for it to be a capsule. I don't need that level of precision. So I can just add a box that does the same job for the purpose that I'm using it for here. You would very rarely notice that something collided when it wasn't supposed to because it hit this corner here. So if the super duper precision you get with a capsule doesn't matter, which is true most of the time, just go ahead and use a box. A box will do this fine. And I'm going to need to give it a rigid body. Let's go back and cheat and see what weight I gave it before. I gave it a 10. I gave it a 0.01. And I also cheated a little bit and turned off gravity. So the thing that's going to make the missile a missile is that it doesn't start out with all of its momentum. It builds up momentum as it goes. So it starts out slow, and then it builds up force because it has like a jetpack or whatever behind it, right? And then we'll add some cool trail art for it actually at the end too. All right, so that is my simple missile. Let's turn that into a prefab for now. Erase it from the scene here. And then let's create a new script that allows the missiles to move around. So a new script, and this is going to be projectile move alt. This is where we are going to add force and stuff to our missile. Okay, so let's do a float for the missile's speed. And we'll do the rigid body as always. We have access to it everywhere in the script. You could also do this if you don't want to link them together every time in the script manually. Let's go and do that because I don't think we've done it that way before. So missile alt. I'm going to link its own rigid body to it. First I gotta actually add this script. Then I'm gonna link its own rigid body to it. Cool. And then I'll make a speed. I'm gonna cheat again and look. I did 100. Let's do 100. Cool. This is how much speed it's gonna get every frame, so you could probably add this to tooltip, speed gained per update, or you could say force exerted forward per update, something like that. Whoops. Right, no semicolon. All right. Like before, it's good to have your projectiles kill themselves. When a projectile has its own move script, I like for it to handle its own cleanup as well. So just have it kill itself at the start with some delay. That way you can set the lifetime on a per projectile basis. And for something like a missile, it usually dies when it runs out of fuel or whatever. So. Cool. Now remember that physics generally should happen in fixed updates, so let's do all of our physics in fixed update. And we have to normalize our vector here first. Well, actually, let's just start with simple moving forward. Start with simple no commitment moving forward. So how do we move the missile forward? Add force, and let's try transform.forward times missile speed. Let's try that out. And I will put my missile in the scene so that we can test it. You can always drag prefabs back into the scene to play with them. And I'm going to move it over here because if I started the scene now, it would just crash into that screen and stop moving. So let's see where it goes. It goes into the ground. Why does it go into the ground? Because I said to move it forward along blue. And forward is not what we would think of as forward to this missile. The direction that we actually want to move in is green, which is actually up, I think. I think I said right earlier. Yeah, that's the up axis. Red is right, green is up. So I could have scaled this missile differently and not had to deal with this. And we'll see what the right way to do this later would have been. But in this case, I'm actually moving up. All right, so now my missile flies that away like I wanted it to, picking up speed as it goes. Cool. All right, I can delete this placeholder from my scene. That's pretty much it for the most basic of missiles. Let's go ahead and add that back to my player shoot. So let's call it public Steam object missile simple. This is a simple self-propelled missile. And we'll comment out my simple force on spawn. We'll go with void simple self-propelled missile. Most of this code is the same, except that we no longer have to do some of that other stuff. We don't have to get the rigid body, we don't have to add the force, and we don't have to have it destroy itself, because all of that stuff is now handled inside the projectile's own movement script. Forgot a semicolon there. So, we don't even really need the reference to the missile here, but we'll keep it for now. So let's go back to my player's script and add the missile, missile alt, and now my guy can shoot missiles. Let's maximize this for the maximum effect. He's shooting balls instead of missiles. I think I forgot to save. Save everything. Let's see. Still shooting balls. What's going on here? What did I forget to do? That's definitely my missile. It's definitely a cylinder. Oh, I forgot to instantiate the missile instead. I still have it as bullet here. Alright, cool. So missile simple, and instantiated that instead. Let's do this. Let's go. Maximize, and here we go. Are you ready? Ah! They're going to space. Goodbye, missiles. Really not the way I wanted you to go, but pretty cool if you wanted to build an anti-aircraft gun or something. Unfortunately, they spawn relative to my bullet spawn, which is at transform 0, 0, 0, which means they start pointing up, which is definitely not what I was going for. Okay, so how do I fix that? Well, again, I put myself into this stupid situation by having an object that was rotated 90 degrees in the first place. That's a pain in the butt. Okay? What you really want to do is just add that 90 degrees to bullet spawn's rotation. And so if you look this up online, you'll come up with a few different answers. The most popular answer you'll find is probably to use quaternion Euler, which allows you to actually specify your x, y, and z angles the way that, you know, we actually think of angles as numbers from 0 to 360, and I'll build a quaternion for you. You can do this sometimes, but this approach generally sucks, and you probably want to avoid manually playing with your Euler or your Euler or whatever you want to call it angles unless you're really comfortable with that stuff. The better way to do, which is a little bit counterintuitive, is that if you want the spawn rotation to be 90 degrees beyond the bullet's spawn rotation, you want to set it to the bullet spawn's rotation and 90 degrees more. You actually want to multiply by, I think it's the x-axis, we'll go with this. You actually want to multiply by 90 degrees. So rather than just setting it to 90 degrees manually, here we've done the bullet spawn's rotation and then plus 90 degrees. In quaternion world, that means multiplying it by 90 degrees. So if I use that as my spawn rotation instead, now I should get a missile that either points forward or sideways, depending on which angle I added here. I think I added the right angle. Cool, forward it goes. And look at it just lodge into that square like a dart. Isn't that awesome? Aren't these fun? Whee, look at him go. Realistic, lovely bouncing effects, already built in. Pretty darn cool, if you ask me. Let's go over here. Spin a little. It's very hard to move this character. I did a very poor job with this controller. Get all these darts stuck in the wall. Now sometimes they hit each other in midair as they come out of the gun. Wow, look at that. I've already finished my game of darts. Stack them up real good over there. Beautiful. Okay. Alright. Next, let's do a little bit of art. Let's do adding a cool trail to my missile. So again, another thing that I encourage you to do in your placeholders to kind of take the place of the actual cool trail that you're going to have later. Let's look at how I did this for the simple missile and just copy it, because a lot of this info is kind of hard to decide. I had to tiddle with it for a while to get it working the way I wanted to. So I'm going to drag my missile alt into the scene, and I'm going to paste that trail component in. You can also add the trail component that comes from, sorry, I actually want to make that an empty game object. I want to add it directly to this guy, so let's call it trail. And then paste that trail in, and let's see what this guy looks like. Okay, that's perfect. I'm actually just going to go with that directly. But let's go over some of the features of the trail so you can kind of see what I played around with to get it this way. So I inherited the scale from the object, but if I kept it at the default, which was up here, the trail was way too fat. Notice right up here, which is huge relative to the missile. So I ended up making it a lot smaller. I brought it down to like here-ish. And then the curve describes what the trail looks at over time. So for like a missile cone, it fades away as you get towards the back of the missile. So I have it start out big and then get small. The time determines how long the trail lingers. So it actually is by time, not by distance. So in this case, as the bullet moves faster, the trail becomes longer because it's just going to linger for a certain amount of time. Setting the time to 1 second. Maybe I can show you if I can grab onto this thing fast enough. 1 second of trail regardless of how fast it's moving. Okay. Min vertex distance determines how many kind of little mini trails it dumps behind it as it goes. If it's moving very, very fast, the trail starts to look fragmented if you set the mini vertex distance too high. With color, I did a gradient from teal to white. And I think those are the only things I changed. You can also turn off, generally speaking, cast and receive shadows on trails. Usually isn't that important, but hey, up to you if you want that to be part of your aesthetic. So I don't remember where that apply to prefab button moved. Where did it go? I know they set it somewhere over here. It's now just like a hotkey. I'll get back to you on that. Anyway, let's just copy this guy in and add him to our prefab over here. Center it properly. Delete this, and let's see if I can make some cool traily missiles. Whee! Look, my missiles have trails. Let's look at them in beautiful full screen. Yay, my missiles have trails. Very nice, cool, cartoony missiles. You can make much more, let's say, realistic looking trails than this, but this gets you pretty far in cartoon land. I like little trailing light effects and stuff on bullets too. Trails are really efficient, so you can have like hundreds of these in the scene and it doesn't really care because they're actually just flat, like two-dimensional pictures of a line, and they don't care. Okay, you notice that the bullets that are kind of stacked up and stationary there still have 1 second of trail, but it kind of blends in because they're not really moving. But as soon as they pick up some speed again, their trail will also resume. Alright, the last thing that we'll look at today, hopefully we have time for this, is to give the missiles a target. So we're going to make the missiles home on a particular target. For this, I'm going to cheat a little and just assign their target manually. Normally you're going to have some way to assign that target, but I'm going to just cheat here. And let's make this on the missile first. So I'll start with the projectile move and we'll go from there. So public game object homing targets. Cool. And we'll do this. We'll do if there is a homing target, so if it's not equal to null, then we'll do something. Otherwise, we'll do missile just moves straight ahead like we had in the first place. All right. So let's compute the distance to the target by taking a vector between where the missile is now and the target. So if we're looking at the thing that we're trying to home towards versus where we are now, how do we get that, the line between us and the target? Well, that's actually as simple as subtracting our 2 points in space. If you subtract the vector 3 of the target from our position, so the missile's current position, like that, then you get the line between the missile and the target. But we don't want to move the missile faster if it's further away from the target and slower when it gets close. We want it to move at a consistent distance. So we don't care how long this vector is. We don't want to know the distance between these 2 points. We just want to know the direction. And whenever we want to know the direction, we normalize the vector to a vector of magnitude 1. So when you call this dot normalized on a vector, you ignore all the magnitude and you put it back to a magnitude of 1. So just imagine a line on the unit sphere, a sphere with a radius of 1, or a diameter of 1. Doesn't really matter. All right, now that I have that direction and I've got it normalized, I can add force in that direction. So I'm going to add force to the target times the missile speed. Now, unfortunately, this doesn't handle the missile looking at the target. So let's play around with this and see what it looks like. I'll drag a missile into the scene over here, and I'll manually set its homing target to testing cube, and then run this, and we'll see that the missile just kind of, oh my, it's gone. Let me undo this. All right, let's look at it in the inspector. The missile will stand perfectly still. What did I forget to do? Oh, whoops, I forgot to multiply by the missile speed, didn't I? Or did I? No, I did multiply by the missile speed. What did I forget to do? Please don't tell me I forgot to save. Let's see. I bet that was it. Yep, that was it. Boy, I've done that a lot today. All right, and you can watch the missile just kind of fly towards the testing cube, but it doesn't spin towards the testing cube, so it looks kind of dumb. It just stays at the angle it was at. So we want it to actually face the target that it's going towards. If you want a realistic missile that slowly rotates towards the target that it's going towards, that's going to be a little bit difficult. You're going to need like rotate towards and slurp and have it gradually move towards there. And then rather than having it just move to the target like this, you'll have it continue to use our original mechanism where it just adds force forward, but then you slowly rotate the missile's perspective forward to face the target. That's the really fun and natural way to do a homing missile that can miss. But this is like a cheating homing missile that always reaches its destination. So we're going to manually make sure that it is always facing its target. And we've done this before. Remember, we've looked towards things, and we've accomplished that with quaternion look rotation. But that's going to bring us to another caveat. Again, we rotated the stupid thing to begin with, so now it's facing up instead of the direction that missiles are generally supposed to face. So once again, we have to do this stupid thing and multiply by Quaternion, Euler, 90F, 0F, 0F in order to get it to look right, which again is dumb. There we go. Now it's going to face the right way, and you see now it's actually facing towards it. So this was kind of annoying. How do we avoid it? What is the thing that we should have done to mitigate having to always do this multiplication by 90? Well, what you should have done is what I did for a lot of these other objects, and that is simply starting with an empty transform. Missile, we'll call this missile good. All right, start with an empty game object. Move that guy around. Put the collider on this guy, on the empty guy, but make a separate game object for the visual part. It doesn't matter if this thing is rotated, okay, because when you spawn this guy in at his true 0, 0 rotation, the parent, this thing will inherit its rotation relative to it, and then you don't have to worry about rotating the original. So as you build your projectiles, as you build your more complicated enemies and stuff, I suggest that you always, or essentially always, start with an empty game object as the root, and then rotate everything in relative space so that you don't have to deal with rotating it in world space like I did here. Okay, so that works. Now I'm going to make this private so that I can't assign it manually in the inspector. And I'm actually going to make it so that it's assigned when the missile is spawned. So we'll call this private void set. I haven't done a lot of private variables, so this will be your example. Set homing target to game object target. Homing target. I cannot spell today. Homing target equals target. Simple as that, little setter method here. And then what we'll do in player shoot alt is that we will set the missile to follow that thing. So we'll call this simple homing missile. And we'll lock onto the game object that's the target here. So we'll call it homing target here as well. And we're going to do all of the same stuff that we were doing before in terms of instantiation and whatnot, but now we are also going to call that script and tell it to lock onto our homing target. So how do we do that? So just like we were able to capture the rigid body from the missile that we spawned before, we can also target the projectile move alt script that we had the same way. So we'll take the missile and we'll get its component, the projectile move alt script, and now we can call that attached method to it. But I always like to verify that the script actually exists before, because you don't want to have a bunch of errors on null, and you want to be able to use missiles that can't home, maybe using the same script. So if the script is not null, then we're going to set, what did I call this? I made it private on accident. Public. Set homing target to the home target. And that allows us to lock it on. Okay, great. So let's try that out. Homing target is going to be old testy cube here. I'll drag him in manually. Let's play with it. I forgot to actually add the script to update. Womp womp womp. Okay. And let's full screen it. This will probably be the last thing we do today, so we got 1 minute to play around. Let's go. Homing missile. No matter where it starts, it homes. I did much better at calculating the force on my other rigid body collider. Don't use this alt one, use the original. This one is trash. But what I'm really trying to do is hit myself with the missile so that I can move with its force. Let's go. Come on. Oh, this guy rotates too much. There we go. Yes. Come on, take me, missiles. Alright, that's all I think we have time for today. I'll be in Discord if anybody has any questions about their project. Next time we'll cover recurring events and maybe something else. We'll see. So if you have anything you want to really look at, let me know. You can watch these cool missiles fly to and fro here as they track onto the target and then track back. Very neat. Now remember, they only live 20 seconds, so you can only get so many at a time. Wow. Does that look cool or what? Okay. See you later, everybody.